Okay, ladies and gentlemen, I'm Jerry Glasser, and I was very fortunate to be an instructor in the SR-71, and this was my home for 4 years. And what we're going to try to do here is give you a 360 view of the instructor's seat, which is the back seat, and the instructor sits in the back, the student sits in the front, and as you can, you'll see we're going to start on the left side of the cockpit. Hopefully the visualization will be good. And what I'll attempt to do is go through all of the instruments for the back seat and show you what the instructor's position is like, which is a very, very busy place. So we're going to start on the left side of the cockpit. You may not be able to visualize this, the camera is kind of tight, but on the left side, you'll see the standby inertial navigation system. This is a backup system, which we'll use, but in case our Astro Tracker, we lose our Astro Tracker, we have another means of navigation. Okay, coming forward, here are 2 throttles, independent throttles, and there's some counters on the bottom of it, which tells us how many TEB or triethyl borane shots we have to start the engines and light the afterburners. Okay, I'm going to remove the throttles. Above the throttles is very innocuous switches. And let me get my camera down here. These are aft bypass switches. We can manually control some of the door situations for the inlet. Most of the time we let the inlets be in automatic, but the aft doors, which is both procedural and technique, we can control the aft doors. Forward of that is the exhaust fan temperature. We have the ability to modify the EGT of the airplane, so both cockpits can do minor maintenance and adjust the temperature. We can't adjust the RPM, but we can adjust the temperature of the EGT and change the thrust ever so slightly on the engines. Forward of that, and I hope I'm doing this correctly, you can see it. We have all our comm switches. There's communication between the back seat and the front seat, and also communication between externally to the tankers and other systems. We're VHF, UHF, and HF equipped. We have 3 means of communication, and we electronically range on the tanker. We don't talk to the tankers, we just electronically range. Okay, coming up on the left side, you'll see a very important gauge. This is our bay temperature gauge, and we try to keep the front of the airplane below 140 degrees. The airplane is fuel cooled. And thermal is the biggest problem for the airplane. We have to keep the airplane, the front canopy gets to 600 degrees, the surface temperatures get to 550, and fuel becomes our coolant. Okay, the landing gear, notice there's no landing gear handle in the back seat. It's only in the front seat. I can electrically deploy the gear, but I can only do it once, and it's only in a basic emergency that I would do that. We leave that to the front seater. Okay, the gear knot lock light. We have our 3 landing gear lights, our anti-skid for landing. But basically, there's no gear handle in the back seat, and there's no parachute deployment handle in the back seat. It's done electrically. Okay, coming up. Liquid oxygen, we have 3 liquid oxygen systems. We need that for flight, convert it to gaseous oxygen, and we pressurize the helmet and let cool air with the suit. Here's our cabin altitude. Basically, we're flying at 26,000 feet, and we're breathing 100% oxygen for the entire time. Coming down here, all our spike indicators, and I'll go back up, but all our spike and door indicators. Normally, the inlet system can be run in automatic. About 95% of the time it works, but every once in a while we can take a spike and manually control the spike, manually control the doors. It's not very efficient. The drag for the airplane is blowing inlet subsonic air into a supersonic airstream. But these are our spike indicators. This becomes a very important gauge. This is our compressor inlet pressure gauge. And basically, when you look at it, it's at 14 plus PSI. And the engine inlet is so efficient that at 80,000 feet, the pressure recovery is about 40 to 1. Outside, it's 0.4. We're recovering to about 16 pounds per square inch. So the engine is sensing 16 psi at the front face of the compressor. And the problem is we do work on the gas, so the temperature gets up to 800 degrees. Next one is a very important gauge. This is our compressor inlet temperature. We are limited, and that's not a Fahrenheit gauge, that's a Celsius gauge, to 427 or about 800 degrees Fahrenheit. That's the inlet temperature of the engine itself. The compressor is sensing 800 degrees. Going up, we have a triple display indicator. It's called a TDI. It's equivalent airspeed. It's not indicated airspeed. It's equivalent airspeed, altitude, and Mach. So if I level off at 73,000 feet, I'm reading about 410 keys. I'm reading 73,000, and I'm reading Mach 3.0. But this is our airspeed indicator, which we really don't use that much. Why? This would read about 520 or 530. The reason is there's a compression error, and we use the TDI to run things. Straight ahead, well, let's look up here. We don't want to see alert light or a bailout light from the front seat. We'd rather not see that. We have we have a chute deploy, it's all electrical. We have a couple of other switches out here for the air refueling. Straight ahead, we have our attitude indicator, and the vertical bar becomes a track bar. When the ANS is running properly, which it does most of the time, once the ANS locks onto stars, we are plus or minus 300 feet any place in the northern hemisphere. Coming down, our horizontal situation indicator, when that track bar is centered, our horizontal situation indicator is centered, and we can deviate, but basically we're flying on the black line plus or minus 300 feet. A map display, which is not shown here, but it's a cut and paste. It's just a map that they cut and paste, and we just set the Mach, and the Mach display rolls, so we have a known position. Never lose sight of where you are. You cannot get lost in this airplane. You just can't do it. Okay. Bottom of that is all our Nav Selections, our TACAN, INS, ANS, and when we're flying missions, we fly in ANS. Come home, we go to ILS, and this just switches all the indications for the cockpit. Up on the right-hand side, next there, a range to the tanker. Remember, we don't talk to the tanker. We just range to the tanker. We have a DME ranging, and we can hook up right away. We just roll up behind the tanker and hook up. Air refueling, engine switches, altimeter, which we don't use that much. When we're supersonic, we use the triple display indicator. The vertical velocity is really not used at all. Basically, we're in a cruise climb, climbing at about 300 feet per minute, but the errors of the three gauges, the errors of the altimeter, the VVI, and the airspeed is significant when you're flying supersonically. Below that, there's a fuel gauge. We can take on about 81,000 pounds of gas. We take off with half fuel, about 45 or 55, and about a half an hour later, we're behind the tanker, picking up 81,000 pounds of gas. Two fire lights, which we'd rather not see. RPM for the engines, EGT for the engines, nozzle for the engines, fuel flow. What's interesting, our fuel flow at the end of the runway when we take off, we light the afterburners. We'll get to the end of the runway at 400 knots, and we're burning 74,000 pounds per hour per engine. So for the first 2 minutes, we're burning 150,000 pounds per hour, and we go through about a little over 5,000 pounds of gas in the first 2 minutes. It takes 5,000 pounds also to taxi out. From the time we start the engines until the time we taxi to the end of the runway, we've burned 5,000. We burn another 5,000, climbing to 25,000 feet, 24,000. So we've gone through 10,000 pounds of gas in the first half an hour, 35 minutes of the airplane. Okay, very important gauge, CG indicator. We're limited to 25% CG. The further you move the CG back, the more efficient the airplane gets, but the more unstable the airplane gets. So we manage fuel to manage the CG. We can manage fuel tanks. Next there we have oil pressure, fuel tank pressure, hydraulic pressure. We have 4 hydraulic systems, and the fuel tank pressure is very important because we need liquid nitrogen to purge the tanks. The fuel gets up to about 300 degrees, and we need to inert the fuel tanks so they don't blow up. So we carry dewars of liquid nitrogen. We convert it to gaseous nitrogen, and we purge the tanks. We fill the tanks and we are pressurizing the tanks at speed with liquid nitrogen. All our fuel tanks, I can press this, I can transfer fuel here, I can aft transfer fuel, so I can move the fuel around and I can move the CG around of the airplane. We take off at about 22%, 22.5%, but as we go supersonic, we're moving the CG back to 25%, which is an efficient part of the airplane. Okay, down here on the right-hand side, we have our autopilot system. It's not rudimentary, it's very good in track, but there's no pitch autopilot. We don't fixate in pitch. There's a little vertical wheel here. And remember, every 1 degree in pitch at Mach 3 is 3,500 feet of change of vertical velocity. So you make a 2 degree change, you're doing 7,000 feet. We're moving the pitch wheel in 20ths of a degree, very, very minute pitch changes. And we cruise climb. If we start at 72, we're kind of cruise climbing to 75 or 78. If we're at Mach 3.2, we're starting at 75 and cruise climbing up to about 82 or 83,000. Okay, coming over here, we have all our DAFIX. This is our, we have a DAFIX program which compares all the computers before we fly. We have our cabin pressure. We can do 10,000 or 26. We normally fly in 26,000 because we want more of the pressurization to be running the cooling for the front of the airplane. Remember, the airplane's going to heat up to 550, and we're going to attempt to keep the front of the airplane at the bays at about 140 to 150 degrees. We don't want to overtemp the bays. Coming back, we have our TACAN. We have a faceplate, but our right side, I don't know if you can see it, is R2-D2. This is our Astro Tracker, and basically designed in 1963. It's a backup system for the B-2 bomber right now, but basically you can't see stars in the morning or when it's clear during the daytime. The Astro Tracker senses stars, and it locks onto 3 stars, triangulates, and basically once the Astro Tracker works, which it works 99% of the time, we do have the INS backup. This Astro Tracker updates the INS, and we are good to plus or minus 300 feet anywhere in the Northern Hemisphere. We have a star catalog. We load R2-D2, our Astro Tracker, with a crane in the back of the RSO position, and basically this navigation system was designed in 1963 and works perfectly. Okay, coming back, we have our modes, how to run the system in the back right-hand side. We have some circuit breakers, and the back seat is quite cramped. You're in a pressure suit. You're both instructing and managing, you're navigating, you're ranging with the tanker. So basically, this is a very intense, when you, even though you have a technically qualified pilot in the front seat, the intensity in the back seat is very high, especially the B model is a great trainer. It'll unstart about 2.4, and we want to show some unstarts to students so they're not surprised. But basically, the back seat is where the money makers are, and as instructors, we would kill each other to fly in the back seat. There's one hole here. Don't worry about that. It's for calm. But if you get a good picture here of the complexity of the back seat, and remember, this airplane was designed in 1963. This design is a 1958 design, and basically flown in 1963. The B model was flown in '64. But it's a great trainer. You get 5 rides in the trainer, and if you have to pass your check ride at the 5th ride, if you don't, you're going to go someplace else. So I hope you enjoyed our tour. We can't see everything; it's kind of cramped, but I think you get a good perspective of the intensity and the complexity of the back seat. And you get 300 hours of simulator time because you have to know every single switch, you have to know what every single switch does, and you have to know where the switches are, and there's no choice. You cannot make a mistake in the back seat. So I hope you enjoyed our tour. Thanks a lot.